In this set of notes, we're going to look at an introduction to data management. Most of the information from this note set is going to come from the book Applications of Regression Models in Epidemiology. If you chose to go with the other textbook, no worries. I'm going to cover all of the relevant information here in this note set. So the aim of data management is to access the data as quickly as possible while ensuring the quality of the data. And the reason for this is generally when performing statistical inference, the idea is we've taken some sample and we want to use the data from that sample to say something reasonable about what's happening in the population. So if the data quality is poor, that data is probably going to end up being biased and you're not going to be able to make valid inference. And so it's really important at all stages that we really ensure that we have quality data and that quality is maintained at each stage, because otherwise it won't matter what analysis we do if our data quality is poor. So we're going to start out by talking just a little bit about study design. So a good study design allows a researcher to answer questions of interest as effectively as possible. And so there's a couple different things here that need to be considered. Again, most of this information is going to come from the text. So starting out, one of the things we want to talk about is the specification of the hypothesis and the testing mechanism. And so hypotheses are stated according to the questions of interest. And so this is why it's so important that when we start a research study, we really narrow down, what question is it that I'm trying to answer. The more specific the question is, or the more well-defined the hypotheses are, the easier it's going to be to collect data that is going to help us answer that question. So there needs to be careful consideration to obtain the right data, and not only to obtain the right data, but to make sure that we use the right analysis to answer those questions of interest. So there's two pieces here. We want to make sure we have a clear specification of the hypothesis so that we make sure the data we collect and the analysis we choose is able to answer those specific questions. The next thing is the choice of study instruments. The study instrument chosen often affects the precision of observations through a type of technology and ease of instrument for both staff and study participants. We want to make sure that as we are collecting data that we standardize those procedures. And by having them standardized, this is going to maximize the uniformity of the data that's obtained. So for example, pre-testing of a study questionnaire, also known as a pilot run, assesses clarity of questions, appropriateness of chosen categories, presence of sensitive questions, and general flow of the questions. So in other words, anything that you're going to be using in your study, whether it be a survey or any instrumentation that you're going to use, you want to do a dry run of it first. So that way when it goes to actually collecting the data, there's less likely to be any kind of hiccups, because anything that you have that occurs along the way may impact the data that's collected. You want to create a manual of procedures. So this one is pretty obvious. You might have multiple people that are collecting data or working on the study. By having a manual of procedures, this is going to provide easy, accessible information on the data quality protocols for everybody involved. That way, no one is guessing about, for example, where data should be stored or how it should be collected, what the timeline is. You want to have, as clear as possible what those procedures are so that no one is guessing along the way. And then right along with that, staff training. Again, everybody should be on the same page. Everyone should know what is happening, so that as the study progresses, everyone knows how to use the instruments, the protocols used there in case there are any problems, and how to process the data effectively. And then finally, if you need any updates in the study procedures, changes are inevitable to happen. So research members need to be notified of pertinent changes to maintain study continuity and avoid any problems. So all of these things need to be considered when designing the study, and part of the importance of all of these is for that data quality. If you have all of these in place, you're more likely to have better quality data. All right, we're going to talk a little bit about data collection next. So data collection is the process of measuring and gathering information on the process of interest, and this information is typically represented in terms of variables. And so here a little bit later on, we'll do a review of different types of variables. So there's two types of data. There are what we call primary data, and there are secondary. So primary data is data that's collected firsthand by the research team. So this is when they actually go out, they see the subjects, they measure what happened, and they do everything firsthand. Secondary data is data that comes from another source. So for example, if there's been data that has already been collected by a government agency, for example, like the CDC, and you go and you find that data set and you use that to answer your research question, you would be using secondary data. And there are pros and cons to each of them. So we're going to look at some advantages of using primary data. So an advantage to using primary data is you collect exactly the data elements that you need to answer your research question. In other words, you're going to have more control over what is being collected. You can test an intervention, such as an experimental drug or an educational program, in the purest way, so as a double-blind randomized controlled trial. And you control the data collection process so you can ensure the data quality, minimize the number of missing values, and assess the reliability of your instruments. So in other words, the big advantage over using primary data is you have a lot more control. You are the one setting everything up, so you have all of the control. Now there are advantages also to working with secondary data. Working with primary data can be very expensive, going out collecting data, whereas if you're working with secondary data, you can get large samples relatively inexpensively, sometimes even for free. Sometimes with secondary data, you can get population estimates. So for example, state data can be combined across states to get national estimates. Again, it's less expensive, it takes less time, and you may not need to worry about informed consent. Whereas if you're working with primary data, you're almost always going to have to worry about getting informed consent from the subjects. But there are issues with secondary data. The study design and data collection are already completed for secondary data. In other words, this is where you're losing that control and you might lose some of the quality. Data may not facilitate particular research questions or information regarding study design, and data collected procedures may be scarce. So in other words, you might have the data, but you might not have the clearest picture of how that data was obtained, and that can be a problem. Certain fields or departments may place less value on secondary data analysis, and they often require special techniques to analyze statistically the data. And this comes from the fact that there may be some data quality issues, or it may be that you didn't get to directly examine the variable you're interested in, so you're having to look at another variable as a proxy for the one that you're interested in. And so for a variety of reasons, you might need some special techniques. All right, so next we're going to talk just a little bit about data entry. So in order to analyze data, you've got to enter it into a computer. So no matter where you pull this data from, whether it be primary, whether it be secondary, at some point you're going to have to read it into the computer and get it into the software. So a couple recommendations for data entry: use code when possible. So in other words, don't have really long descriptions for your categorical variables, code them instead. Use appropriate software, and keep a code book. So you always want to have a code book, because if you're going to use codes, you need to know what those codes relate back to. All right, we're going to talk a little bit about data screening. So data screening consists of checking the data for unusual observations, and occurs prior to the analysis during the exploratory analysis. So unusual observations may be correct or may be due to an error in the data entry. And we'll discuss unusual observations that are entered correctly later on in the course. So we're just going to look at some tips for data screening. You want to start screening your data early in the project. So by starting early, one can change patterns of ineffective data entry, data collection, or correct any errors by contacting respondents. Now, if you're working with secondary data, this step has already been done, so you can't do this. You want to check if observations are feasible. So for example, if one of the questions you ask respondents is what is your age, and somebody says 400, well, is that 400 years? Because if so, that's not a possible value. So you know that something has gone wrong there. Is it 400 months? If so, that seems like an odd way to enter that. So again, there's multiple things that can happen here. So always be looking for values that just don't make sense. Do you have somebody with a negative weight? Do you have somebody with, negative whatever value that must be positive? So look for these things as you go through. And if you check these things early on, as you're entering data or as you're going along, you're likely to catch something that was incorrect and fix it so it doesn't occur later on. Counts should be made of non-changing categorical variables at different time points. So for example, one can check if the total number of males and females at baseline matches with the total number of males and females at follow-up. So that way, that's a quality check that you can do, that if you know there's some count variable that shouldn't change from pre to post, you can check from pre to post to make sure that those are still the same. Do categorical entries at different time points make sense? So this is another thing that we can look at. For example, if a person at baseline says he's formerly smoked, but at follow-up an entry of never smoked is a sign that something went wrong. So that's another thing that we can check to make sure that things add up. And then finally, the last thing I've got here is always comment your code. There's nothing worse than going back to code that's a month old or 2 months old or 3 or 4 years old and wondering what was going on here. The more you comment your code, the easier it is to read and the easier it is for other people reading your code to understand what's happening. All right, we're going to review types of variables. You have more than likely in your intro stats course seen all of these before, so this should be all review. So there are 2 different ways that we are going to classify variables. They are categorical. This is also known as qualitative, and quantitative. Categorical variables divide the cases into groups, and so it places each into exactly one of 2 or more categories, whereas quantitative measures some numeric quantity for each of the cases. And so we're going to break categorical and quantitative down into different types. So the first type of categorical variable is nominal. So nominal have no intrinsic ordering to the category. So an example here could be gender, or county of residence, or disease status, yes, no. There's no real ordering here. It's just you fall into one or one of the other categories. Ordinal, on the other hand, are categories that have a clear ordering. So for example here, it could be stages of cancer, or low, medium, high. And then finally, the other type is dichotomous. So dichotomous only have 2 outcomes. For example, vaccinated, unvaccinated. And you should note that both nominal and ordinal could be dichotomous. Now for quantitative variables, we're also going to break them into 2 different types. So again, quantitative variables measure a numeric quantity for each case, and numeric operations make sense for these variables. So be careful here. If we ask a subject their zip code is numeric, but it doesn't make sense to talk about average zip code or maximum zip code. So even though we record zip code as numbers, it really is a category. So when we say quantitative, it's not only do these variables have number values, but it's can it or does it make sense to perform numeric operations on them. So we say that a quantitative variable is discrete if its possible values form a set of separate numbers. And so in a public health setting, one of the most common types of discrete variables are count variables. Count variables are variables that can take only positive whole number values, so 0, 1, 2, 3, etc. And some examples that you might encounter are things like number of alcoholic drinks, number of doctor visits, and number of missed doses. A quantitative variable is continuous if its possible values represent an unlimited set of possible values, or we could say that they exist on some interval. So, for example, we could look at things like BMI, weight, and blood pressure. Those are all continuous quantitative variables. The last thing we have in this note set to talk about is causality. So, one of the central objectives of epidemiology is to assess the causal role of specific exposures in the occurrence of disease or other health outcomes of interest. A detailed discussion of causal inference is way outside the scope of this course, but there are a few guidelines that you should be aware of when talking about causality. So the first one is strength of an association. So remember that association does not tell us that there is causation. You can have associations without causation. But if you have a really strong association, that might tell you to explore further to see if there's a causal relationship. So be really careful with that distinction there. You can have very, very strong associations with no causation, but if you have a strong association, you might want to examine or explore to see if there is causation. Biological gradient. So what this says is it's talking about a dose response evidence. So in other words, if there are higher levels or intensity or duration to some exposure, is there a greater risk to developing that disease under study? If so, that might be evidence for causation. So one thing to think here, if someone smokes 1 cigarette a day versus 2 packs a day, is the person who smokes 2 packs a day more likely to get lung cancer than the person who only smokes 1 cigarette? That may be evidence of causality. Temporal sequence. This says the timing assumes that the exposure factor precedes the development of the disease under study. In other words, did they have the exposure before the disease? Because if the exposure occurred after the disease, then there may not be evidence of causation there. Consistency of findings. This means that the observed association between the exposure and disease is similar to previous studies with different designs and different populations. So in other words, this gets to this idea of reproducibility. We should be able to reproduce these results under similar experimental conditions. Biological plausibility of the hypothesis. So this means that the observed association is compatible with the existing knowledge about the pathophysiology of the disease. However, the absence of this criterion is not sufficient to exclude causality. Coherence. This implies that the study's findings do not conflict with existing theory and current knowledge. Specificity of association. So this indicates that the factor or cause under the study produces the disease and that the disease must result from a single cause. Experimental evidence. So in your intro statistics course, you probably learned that you really need an experiment to show causality. And so the experiment requires studies of different nature, whether it be clinical trials, community trials, and laboratory studies in order to provide evidence for causation. And then finally, analogy. If some other similar agent exerts similar effect, then it's more likely the association is causal. Now, none of these by themselves will show causation. When we think about causation, we're really looking at all of these things, or all of these things present. And if so, then there probably is a causal relationship there. So showing causation can be a very tricky thing, and we want to make sure that we do our due diligence when trying to show that there is a causal relationship.